Hey there, it's Tim.
And Robert. In this episode of National Parks and the History of Science, we visited Indiana Dunes National Park to explore one of the central ideas in the science of ecology.
And that idea is plant succession, or how the plants in a place change over time. It happens because one set of plants alters their environment. They provide shade or nutrients or moisture to the soil, which allows some other set of plants to come in, grow, and replace the original plants, and so on.
You're probably familiar with it. Succession is why you have to weed your garden or mow your lawn if you don't want bushes or trees to take over.
The science of all of that began in the 1890s on the sand dunes of northwestern Indiana. Let's check it out.
Indiana Dunes National Park is at the southern tip of Lake Michigan. Glaciers and winds have created a series of sand dunes in the middle of North America that are home to a unique collection of plants. Dr. Noel Pavlovic is a plant ecologist with the U.S. Geological Survey. He's been studying this park for more than 30 years. We hiked from the water's edge to the top of the oldest dunes. Our journey was a walk not just through different plant communities, but through time.
Henry Chandler Coles was a student at the University of Chicago, and he came out to the dunes in the late 1800s and started observing what was happening on this very dynamic landscape starting at the beach. And he discovered the process of succession. He interpreted the changes in space as being equivalent to the changes in time. So vegetation changes as you go inland, and that's how the vegetation would have changed in time at one spot.
We began our walk through space and time just a few steps from the beach. So, it's a lot more green here up on the dunes. I'm wondering, is this plant succession in action?
Yes, it is. This is one of the first stages of plant succession. We have behind us here the marram grass, and it grows by roots and rhizomes. And then we have in front of us the cottonwood tree, which grows upward, and as it gets buried, it sends out new roots.
What's significant about these plants in terms of succession?
Well, in succession, they're doing several things. First of all, they're stabilizing the dune while it's growing upward. And then their roots are going into the sand, and they're starting to add organic matter. And that's the first stage of forming a soil, which is going to develop in time as succession proceeds.
And when you say adding organic matter, do you mean the plants are actually dying and then enriching the soil?
Yeah.
That's kind of macabre, isn't it?
So that's a good question. Plants have bigger roots and they have finer roots, and the finer roots are more dynamic. They're the part that searches for nutrients in the substrate, but they have a life cycle of their own, and they'll die. And those parts that die will contribute organic matter to the soil, and other parts of the roots will continue to grow into the searching for more nutrients. So that's how it works.
Onward we went, just 100 feet inland, and plants were obviously different.
We're behind the dune that the marram grass captured, and there's less sand blowing into the surface, so it's been stabilized. And this particular grass that's here in bunches is called little bluestem grass. It does not like to be buried by sand, so it has invaded here, and perhaps the soil is a little bit richer, and you'll notice that there's bare spaces between the grasses. And we have other plants that are coming in, like the orange puccoon here. So there's more plant life here. When Coles was here, it was a much more stark landscape with more dynamic sand movement and destruction of vegetation, which is a process he called rejuvenation. I've been here 36 years, and so one of the things that I've noticed in this particular area is that there's a lot more shrubs, the ones behind us. And so we're actually shifting from this, what I would call a secondary dune vegetation, to a shrubland. And it's possible that this may become forest, or it may become marram grass again. It just depends on the dynamics.
We walked a couple of 100 feet more and started to see some big changes. Could you tell us a little bit about the area we're in now?
Yeah, so we are further inland, and we're seeing more shrubs, and we've got more soil development, and that's why the sand is a little bit grayer here. And then behind all of us, you can see in the background jack pines. So pines are invading, and this is going to become a pine forest. And then oaks like to invade underneath the pines, and so then the pines eventually give way to oaks.
So if we look carefully, we might actually see little oak seedlings, perhaps?
That's right, we probably will.
Further inland, past bushes and trees, over a storm-blown dune, to a place that didn't look like sand dunes at all. Noel, we have made our way through the pines, and now we're in a hardwood forest. Things are completely different from where we started out.
Yeah, so we're actually about 150 feet above Lake Michigan, and we're still on sand. And we have behind us a beautiful example of red oak trees. And we have some witch hazel in the understory, and to our left there's basswood. And on the ground we have a lot more leaf litter, and you can see in spots that the soil is dark gray. It's not sandy at all. You would actually have to dig a couple inches to find sand that looks tan colored.
Back to Coles and other scientists at that time and a little bit later, what was the mechanism that they were suggesting was driving this successional change in plants?
You know, succession is the driver of vegetation change, and disturbance is the process that resets the clock back. So if we had a tornado come through this and knock down a bunch of trees, the forest would change. And it might change back to what it is today, or it might go in some other direction. And that's sort of what ecologists try to do. They try to understand the processes in the landscape.
Succession versus disturbance, an interesting back and forth. We'll come back to that in a moment, but first, we went to the top to see if succession ever ends. Can you tell us a little bit about this place, this climax community? I believe that's what it's called, right?
Yeah, so we're in the transition from the red oak forest there to the black oak forest behind us and to our left. And also you'll notice on the ground that there's a dark soil there with leaf litter. So we've come a long way, and we're at what's the climax for vegetation in the Indiana Dunes. Coles recognized that the changes he was seeing had to do with the changes in the environment and how the different species with their particular adaptations could respond to those changes. And so he didn't necessarily see succession as always going in a particular sequence until you reach the climax. And he also recognized that it could go backwards. Sands could suddenly blow up here and bury these trees, and we'd start over again. So he found in the central dunes a stark example of the struggle for life and how the change in communities was driven by the change in environmental conditions.
We saw succession on our walk with Noel, but why does succession matter to most of us? Well, that back and forth between succession driving change forward and disturbance setting it back is fundamental to how people interact with nature. For thousands of years, humans around the world have disturbed landscapes in order to encourage certain plants and discourage others. That's exactly what you do when you mow your lawn or tend your garden. And it's what land managers like national park staff do when they periodically set fires in the park. They're applying the science of succession to the management of our public lands.
Fires in this area were believed to have originally been set by lightning, and then our indigenous people here used fire on a regular basis to do a variety of things, clearing the landscape so they could see, bringing in new vegetation so animals would come and browse, and then it made it for easier hunting. So if you look at this side, this is a side that's had fire applied many, many times, and you'll see the structure is very open. You have the trees, very little shrub density. You can see through these woods. And if you look at this side, you can see what happens when fire isn't applied. You see a lot of woody stems coming in, a lot brushier. We also have some prairies in the park that we burn more frequently because we want them to be open grasslands with no woody species in them. We want a lot of heterogeneity within our landscape because that's what we have to begin with.
So the science of succession is interesting and important for how we all live in the world. But Coles and other scientists didn't just shed light on succession. Because of their science, they saw that these dunes were unique, so they lobbied for federal protection, which was granted in 1966. These dunes are a shining example of how scientific value can go hand in hand with conservation in our national park system.
Henry Cole sponsored a team of European scientists to come to the United States and, ask them what they wanted to see. And it was a pretty interesting list where they talk about Yellowstone and Grand Canyon and Yosemite, but also southern Lake Michigan. And that even in the early 1900s, the word was out globally that this place had significance to science. It's clearly a special place.
Those dunes are definitely a special place. It was good to be there.
And what a legacy. I would bet that over 1,000 scientific studies get published every single year, even now, that either focus on succession or use it as context.
And to think that plant succession has its roots in a national park.
See you next time on National Parks in the History of Science.